68% of the fresh water on Earth is stored in two giant ice sheets, thousands of meters thick, covering most of the surface of Greenland and Antarctica. These were formed from snow, becoming compressed over many centuries under the remains of the last ice age, a time when ice sheets covered much of northern Europe and North America. Over time, the ice, moving under its own weight, gradually flows towards the coast. This eventually forms ice shelves that float on the ocean. These in turn carve into icebergs and melt away in the relatively warmer oceans. New snowfall helps to replace the ice, but is this sufficient to prevent the ice sheet flowing away? Measuring the overall gains and losses is important because when the water from the melting land-based ice finds its way to the ocean, it contributes to a rise in sea level. Accurate measurements taken using satellites have found that the amount of ice is steadily declining, particularly in Greenland and western Antarctica. As an ice sheet melts, its height reduces, which exposes the surface to higher temperatures at lower altitudes, causing yet more melting. This reduces the level even further in a vicious circle. Currently, this could be stopped if we halted the rise in global temperatures, but that may not always be the case. If this continues, it could lead to an irreversible decline, a climate tipping point. It is thought that for some parts of the ice sheets, this could occur soon with our current rate of warming. Preventing global sea level rise would then become an even greater challenge.